So a lot of people have this understanding that with the rise of AI and robotics, a lot of jobs will be displaced. There are reports saying that 20,000 of manufacturing jobs will be lost by 2030. However, with AI and robotics, it's actually also pushing innovation and enhance efficiency. With that, our livelihood also increase, and it brings about new kind of jobs like data analysts, software developers, and social media specialists.
Before I begin, I just want to do a warm introduction about myself. I'm currently a robotics trainer. I'm also the training and curriculum lead in Robotics and Automation Center of Excellence. PBA Robotics does many different kinds of research and development, and they are also a local robotics manufacturer. I actually come from Singapore Poly. I was learning aeronautical engineering, and from there I went on to learn about electrical and aerospace engineering, and that's where I had my first ever formal robotics training. In industrial robotics sector, we have basically three major branches where there's manipulators, there's mobile robots, and there's automated material handling robots. So most of the robots are being used in the logistics industry to really speed up the process of manufacturing. So this is one of the robots, what we call parallel manipulators. Right. So what this robot does is it picks and places. These robots, they will be installed in their manufacturing line to help them improve on their quality. Then there's something called the collaborative robots that work together alongside human workers. So imagine you're doing something and then you put it on the side and then the robot arm picks it up for you. Other types of robots are mobile robots, but the main application of mobile robots are in the logistics or warehousing industries. They are able to move in the environment. One of the main key tasks that it does is it transports one item from one place to another. So for this part, I'm going to show you more about what are skills that are being used right now in the industry, and what are the skills that are prevalent as part of a robotics engineer. One of the key things that I found out is mechanical design becomes an essential skill for robotics. Building robots, you would have different types of designs. The use of CAD, right, computer aided design software to design a machine, it makes it a lot easier, and you are able to prototype different designs. Two of the more famous types of CAD softwares are SolidWorks or AutoCAD. CAD softwares that helps you design mechanical parts, and then you assemble them together, and it becomes one solid piece in the assembly. You can also get out from CAD softwares is being able to see what type of load is being stressed on it. Right? Another key skill is electrical and electronics. You need them to prototype, solder some of your components, and then you need to know a little bit of signal processing. You're building a robot and you want to control. So control theory is one key skill of it. PID or PWM, there's an Arduino board. What it does is it's able to give out signals to move the motor or take in a sensor, etc. And that's a key building blocks of what a robot is about. Another key skill is embedded systems, or I would call it, generally call it programming. It's a specialized hardware, and you can learn a little bit of programming to make something simple like make an LED blink or make a sensor. Currently, Python is the easier route in to start learning. There's many different kinds of syntaxes, many different kinds of basically how the language was structured. After learning the key concepts, maybe you can go on to learn about C or C++. If you are a hobbyist, Arduino is a great way to start. If you move forward, what we can do is level up to the Raspberry Pi. It can help you do more complex calculation. Right now, I'm moving into another field, which is about software engineering. And this is where the AI part comes in. Image processing is often used in automation to inspect products. It captures the image using cameras, and then it will process and say, hey, is this product is there a defect or not? The robotics industry worldwide is pretty much what we call open source. So the guys that actually created that platform is called Open Robotics. So from there, people pick up, people study what you did. When there's so many people in the open source community, everyone upskills faster. So another skill also is learning how to Google the specific thing that you want. Probably I'd like to add one more part about one of the skills is being able to integrate the different parts. That is the mechanical design part, being the electrical part, and then there's the software part, and then there's the image or like the algorithms part when AI comes in. Being able to integrate them and knowing where they all come in, that itself is a core skill. The one of the first few levels of software or development or some AI or machine learning practices is having a drag and drop software. This thing called Scratch. Scratch is online, it's free. Next up, we're going into another degree of difficulty and depth of understanding. Going down is the ability to use different image processing library. So if we learn what we call libraries are data sets. Let's use quality control as an example. And if you want to scan your product, you would take different angles. You will take photos of different angles of your product. So the algorithm will learn more about how the product actually looks like. And then you start to learn the concepts. But a more advanced level is to understand the mathematics behind this. Right? There's a lot of algorithms that go beyond this. And one of the key things is that Pythagoras theorem. There's many different ways for you to go about acquiring this knowledge in robotics and upskilling yourself to be a robotics engineer, etc. One of the ways through WSQ courses or skills futures, short courses. If you want to have a more compact learning pathway, you can join some skills bootcamp. Some of the more known ones are General Assembly, where they put you through 3 months or 6 months or something like that, and then you go on to apply them. The SG United programs, what they do is that they put some of the current workforce into 6 to 9 months long programs for them to learn more about the industry, pick something up, and eventually be skilled enough to join or enter the specific industry that they're in. And another way for you to increase your level of understanding is definitely through work experience. I put there the last one, university education, doing research, 2 year, 3 years thesis on a particular topic that will give you your depth of understanding. There's no one right way. So explore your different options and explore how you want to get about to pick up your skills in robotics.
What are the career growth deployment sector in Singapore? Already have a bachelor degree. Do you suggest it for a master or grad diploma degree for me to specialize in a particular department?
So having a master's will definitely gain you some more insights into that particular sector and bring you another level of understanding, right? I would suggest this way. Maybe you can use a skills map. The Ministry of Trade and Industries and MOM has conducted this study where they have mapped out the different skill sets that are useful in different industries. So robotics right now is a pretty new sector. There's no skills map for that, but you can look under precision engineering. You can look under infocom technology. Maybe you want to try to see which discipline you want to go into, whether you want to go into software or whether you want to go into safety. That's even part of robotics, or you can go into mechanical design, etc. So these new technologies creates new jobs that we wouldn't have even have thought of.
Comparing us with other robotics arena to a bigger technology country like China and India.
I believe Singapore as a neutral party to a lot of different countries and also as a business hub. Ultimately, what makes us competitive is our ability to have bilateral ties with a lot of these powerhouses, meaning it's able to share some resources and get some resources with powerhouses like China and India, and being diplomatic and being a neutral party. It makes us competitive in a sense that when China shares some of the technology, some of the universities in Singapore are being invited over. In my personal opinion, Singapore being its diplomatic stance. I think that's what actually makes us competitive.